This is question 13 from the 2022 GCSE Mathematics Higher Tier exam and tests our understanding of Pythagoras' theorem and the area of a circle. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. We've been given a diagram of a right-angled triangle and 3 semicircles. The diameter of each semicircle is one of the 3 sides of the triangle. The semicircular regions are identified by the letters A, B, and C. And the question tells us to show that the area of region A is equal to the sum of the areas of regions B and C. The diameter of a circle is the distance from one edge of the circle to the opposite side, passing through the center of the circle. For a semicircle, the diameter is the straight edge. The radius of a circle is found by halving the diameter. The area of a circle is the product of pi and the radius squared, usually expressed as pi r squared. And the area of a semicircle is exactly half the area of a full circle. Pythagoras' theorem states that for a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. Mathematically, we express that as a squared equal to b squared plus c squared, where the 2 short sides are identified by the letters b and c, and the hypotenuse, which is the longest side opposite the right angle, is a. Answering this question is a 4-step process. First, we need to recall Pythagoras' theorem, and representing the length of each side of the triangle with a letter, find an expression for the area of each semicircle, which we can then use to demonstrate that the relationship between A, B, and C given to us in the question is correct. The relationship between each side of the right-angled triangle is given by Pythagoras' theorem, which states that a squared is equal to the sum of b squared plus c squared, where a is the longest side, the hypotenuse, and b and c are the 2 shorter sides. Each letter also represents the diameter of each corresponding semicircle. A is the diameter of region A, B is the diameter of region B, and C is the diameter of region C. The area of a circle is given by the formula pi multiplied by the radius squared. The radius of a circle is half the length of its diameter. So for region A, the radius is half of A. For B, the radius is half of B, and for C, the radius is half of C. Each semicircle is also half the size of each corresponding circle. The area of A is therefore half of pi r squared, where r is A divided by 2, so half of pi multiplied by A divided by 2 squared, which simplifies to half of pi multiplied by A squared divided by 4, which is equal to pi divided by 8 multiplied by A squared. The area of B is also half of pi r squared, where r is B divided by 2, and so half of pi multiplied by B divided by 2 squared, which simplifies to half of pi multiplied by B squared divided by 4, which is equal to pi divided by 8 multiplied by B squared. The area of C is also half of pi r squared, where r is C divided by 2, and so half of pi multiplied by C divided by 2 squared, which simplifies to half of pi multiplied by C squared divided by 4, which is equal to pi divided by 8 multiplied by C squared. The relationship between each side of the triangle, and therefore the diameter of each circle, is A squared equal to B squared plus C squared. By association, that means we can give the relationship between the area of each region as pi divided by 8 multiplied by A squared equal to pi divided by 8 multiplied by B squared plus pi divided by 8 multiplied by c squared. Each term of this equation has the coefficient pi divided by 8. So, pi divided by 8 is a factor of each term, which can be cancelled, giving us a squared equal to b squared plus c squared, which in the context of this question is the area of A equal to the area of B plus the area of C. Answering this question successfully relies on our understanding of the properties of a circle, its diameter and radius, the relationship between a full circle and a semicircle, and that Pythagoras' theorem connects the ratio of the sides of the triangle to the ratio of the areas of each semicircle. Please follow us on Instagram, TikTok, and Threads for daily maths content.